Not a normal kind of silence, but something so immense it feels as if the universe itself has paused, suspended in the darkness between stars. Far beyond the faint glow of distant suns, space is not truly empty. It carries motion too subtle to see directly, only understood through traces left in light, gravity, and radiation. For most of human history, the sky appeared fixed, a stable pattern of unmoving points. Modern astronomy has revealed something far less calm. The cosmos is constantly shifting. It expands, collides, fractures, and rebuilds itself across distances that defy imagination. And sometimes, fragments from that vast activity do not remain far away. From beyond the outer limits of the solar system, something ancient begins moving inward. It does not arrive with spectacle. There is no flash, no sudden disturbance. Only a faint, fast-moving point of light slipping quietly across the background of stars. Telescopes begin tracking it, and almost immediately its motion stands out. At first, familiar explanations seem enough. Perhaps a comet from a distant reservoir, or debris from a shattered asteroid long forgotten. But as more data is gathered, those explanations begin to weaken. Typical comets react clearly to the sun. Ice turns to vapor, forming a glowing cloud and long streaming tails shaped by solar radiation. This object does not behave that way. It remains compact, sharply defined, showing none of the expected features. The absence itself becomes the first mystery. Then its path reveals something more significant. It is not bound to the sun. Its trajectory is open, a hyperbolic curve that enters from deep space and will not return. This is not a member of the solar system. It is passing through. It has likely traveled for millions, perhaps billions, of years between stars. During that time, it has been shaped by radiation, collisions, and gravitational encounters. What it carries is not just material, but history from a system far beyond our own. As it comes closer, details begin to emerge. Its surface reflects light unevenly, suggesting a complex and irregular structure. Bright and dark regions shift as it rotates, hinting at varied composition beneath its exterior. Thermal observations add another layer. Heat is released unevenly, not in a smooth pattern but in pulses. Something inside responds to warmth in unpredictable ways, possibly trapped materials or fractured internal layers reacting to solar energy. Then small bursts are detected. Brief jets of gas and dust escape from isolated regions. They are not steady, but irregular and fragmented. These subtle outflows slightly alter its motion, showing that even a small body can influence its own path through space. Analysis of its composition reveals complexity. Carbon-rich compounds, crystalline ices, and unusual minerals suggest formation in an environment shaped by intense processes. It is not a simple frozen remnant, but something chemically evolved over immense time. Nothing about it breaks the laws of physics. Instead, it shows how familiar rules can produce unfamiliar outcomes under extreme conditions. The result is something rare, but not impossible. This leads to a broader realization. Interstellar space is not empty. It contains drifting objects like this, scattered across vast distances. Each one carries fragments of its origin, preserved through long isolation. These objects act as natural carriers of material between star systems. Over immense spans of time, they move chemistry, dust, and structure across the galaxy. Planetary systems are not completely separate. They are loosely connected through this slow exchange. Some scientists consider what this might mean for chemistry on a larger scale. If organic compounds can survive such journeys, then the ingredients for complex chemistry could spread between systems. Not created in one place, but shared across many. As this object moves away from the Sun, its activity fades. The brief jets weaken. Its brightness dims until it blends once more into the background of stars. It will leave entirely, returning to the darkness between systems. Its passage leaves more than measurements. It changes perspective. The universe is not a collection of isolated islands. It is a continuous environment where motion and exchange never truly stop. Even in the quietest regions, there is movement shaped over unimaginable time. And beyond what can currently be observed, countless other objects are likely following similar paths, unseen and silent, carrying fragments of distant worlds through the vast dark. What appears empty is not empty at all. It is the space through which everything travels, where change never ends, even when everything seems still. Long after it fades from view, the story does not end. Its passage leaves behind a question that continues to unfold in silence. If one such traveler can cross the gulf between stars and briefly reveal itself, then how many others are already out there, moving unseen through the dark? The instruments that detected it were never designed to find a single object among the vastness of interstellar space. They were built to study planets, stars, and galaxies. Yet, by chance and persistence, they caught a glimpse of something far older than the solar system itself. That realization changes the search. Attention shifts outward, toward the possibility that these visitors are not rare anomalies, but a hidden population waiting to be noticed. Astronomers begin refining their methods. Surveys grow more sensitive. Telescopes scan wider portions of the sky, looking not for bright explosions, but for subtle motion against the fixed background of stars. The challenge is immense. These objects are small, dark, and fast. They do not shine on their own. They reveal themselves only briefly, only when geometry and timing align just right. And yet, patterns begin to emerge. Tiny deviations in motion, faint signatures in reflected light, slight irregularities in trajectories, each becomes a clue. Slowly, a picture forms. Interstellar space is not just a void with the occasional wanderer. It may be filled with countless fragments, each following its own silent path. Some of these objects may pass through star systems without ever being noticed. Others may interact more strongly, influenced by gravity, heat, or collisions. In rare cases, one might even be captured, becoming a permanent member of a new system, its origin forever hidden unless carefully traced. This possibility leads to an even deeper implication. If material can move between stars, then the boundaries between planetary systems are more porous than once believed. Dust, ice, and complex molecules may not be confined to the place where they first formed. Instead, they can migrate, slowly blending the chemical stories of distant regions of the galaxy. Over immense spans of time, this creates a kind of quiet continuity. Not a rapid exchange, not a dramatic flow, but a gradual mixing that links systems together. What formed around one star might, millions of years later, become part of another. Back on Earth, the data from the object continues to be analyzed long after it has gone. Every measurement is revisited. Every anomaly is tested against new models. The goal is not just to understand this single traveler, but to prepare for the next one. Because there will be a next one. Somewhere, far beyond the reach of current observation, another fragment is already moving. It may have been traveling for longer than human civilization has existed. It may have passed through multiple star systems before ever approaching ours. And when it does arrive, it will likely appear the same way, quiet, subtle, almost easy to miss. But now, the perspective has changed. The sky is no longer just a map of distant lights. It is a dynamic field where unseen motion is always taking place. The silence is not empty. It is active, layered with processes unfolding too slowly or too faintly for immediate detection. There is also a more profound shift, one that extends beyond astronomy. The idea that matter moves between stars suggests a universe that is not divided into isolated regions.